So spreadsheets have 25 functions built into them. Google Sheets and Excel have the same functions. And we've made a little story in this spreadsheet. We're going to walk through it and use all of the spreadsheet functions. And that's going to help us learn what they are and how you use them. I'm Adam Steinfurth with SheetsHelp.com, and I'll see you in the video. All right, so what we're going to start with is two dates that we have here, but the dates are composed of numbers that are in separate columns. So what we're going to have to do is we're going to have to find a function that combines these numbers to make them into a date, and then we can subtract the two to find the duration. So we're going to be keeping track of what we're doing over on the left, and we'll use the date function to combine the numbers into a valid date and time. So we'll check that off, and then we're going to use days, which is a type of duration function. So duration would be between two periods of time, how much time is elapsed, right? So we're going to be using that in a second, so we'll check that one off. And let's come back over here. And I said the first thing that we're going to do is we need to combine these dates. So we'll do that just in its own cell here before we construct a larger formula. We'll use the date function. And it needs a year, month, and day in that order. So I'm in the United States, but the order doesn't change. It's always the largest to the smallest, right? So it wants year, month, day, even though here I would say this date is December 10th, 2022. Date function is always the same no matter where you are. So it helps to standardize date input. And when I hit enter, it's turned this into a valid date. All right, so we're going to check to make sure that is a valid date by using this kind of orphan of a function, and I'll tell you why I say that in a second. But we're going to ask, is this a date? So we'll say is date. We'll run it on that, and it says true. All right, if you were to run date on just the month here, let's say that's M6. It's going to come up as false. So we can see that the date function is taking numbers that aren't dates and turning them into dates. Let's delete that. And we just used isDate. I called that an orphan because when you go to insert function, it's listed here as a date function. So it's listing 26 date functions. But when you go to Google Sheets actual documentation and go to the date and time section, there's 25. I threw that in as a bonus, so we don't get to check it off on the left, right? But that's okay. We talked about it. So let's go back to our main objective, and that's to determine the growth rate of the oak. And then as we go through this later, we're going to compare it to another type of plant. And to arrive at the number of days, there is a built-in function called days. We're going to use it. It is a little bit funny that it exists because it's really just subtraction, but that's okay. We'll use days. But be careful, it wants the end date first, which would be the same thing it would want if you're doing subtraction, right? Because you want the larger number and then you want to subtract the smaller number. So we're going to stop right there. We're going to talk about what I mean by larger and smaller. Let's go back and look at December 10th, 2022. If I use the date function again, it's going to say December 10th, but if I display that as a number, so I'm not going to change the actual value, I'm going to change how we view it. It's 44,905. So that's 44,905 days since Google Sheets decided that one day happened to be 0, next happened to be 1. If I go to this date here in September and I run the date function, and I turn that into a number, it's 44,461. So by saying larger, I mean later, but this is the number of days that pass between these two because each day gets assigned a value of 1, and it's a serial number, so each subsequent day is 1 more. So when I run the day function, you can kind of see what it's doing by looking at those two numbers. So I will say days, and then I'll do the date function to put together the end date. All right, separate the two by a comma. And the start date is over here on the left. Hit enter, And there's 444 days between these two dates. And we'll double check that math. So we did these serial numbers before. We'll take this one. We'll subtract this one over here, 444. So now you see what the days function is doing. Let's say instead we want to see that in years. So a barbaric way to do it would be to divide 444 by 365, right? But some years have a leap year, so that really isn't that accurate. So there is a function called YEARFARC. So we'll come over and we'll check that off. And this is going to return the length of time in a year, including the fractions, right? So we will say YEARFARC, and you'll recognize this pattern in between. But this one wants the start date first. So just remain aware of which date it's asking for. We'll have to put them together with the date function, comma, end date. And then the end date will be here. And the YEARFARC function can be done at this point. You can also specify a day count conventions. We'll take a look at that real quick. We're not going to do it. But if you wanted to, we'll look at the YEARFARC reference here on Sheets Help. And if you wanted to specify a different type of method to count the days, you could do that. We'll talk about this a little bit at the end of this tutorial when we look at the days 360 function. But typically you're not going to be doing that. You might do that if you're in the banking industry. But we'll say we're done with the YEARFARC function. And this took 1.2 years. Let's reduce the rounding on that. That's a little bit silly looking. We'll just do that. All right, but if you want to say this in more of a conversational way where you want to say, oh, it was 1 year and 17 days, whatever the number of days is, we can use something called the DATEDIF function, and we can combine the DATEDIF function with a technique for putting words together in a formula just by using an ampersand. So first we'll say, this is a word, right? And then use the ampersand and you can append another word onto it. If you hit enter, you see that's just made a longer string. So what we're going to do here is we're going to use the DATEDIF function, and it wants a start date. An end date. And then the number of units. So first we're going to say years, and we will look at the result. So DATEDIF function is saying, hey, there is a whole year that elapsed, right? So we want the whole year, but then we're going to adjoin that with space, and then we'll say years, and now we're going to have the number of days. So we'll use a DATEDIF function again. So this is actually pretty cool. We're going to copy DATEDIF. Say copy, paste, and instead of y, we're going to say the remaining number of days after a year has elapsed. And we'll come down, we'll see if we can see that here. I think it's going to be yd. So we'll say yd, and that should be returning, there it is, 1 year and 79. So I already see it's only a singular year, so we'll take the s off of the years. And we're going to come down and we're going to say space, days, period, end of sentence, boom, 1 year and 79 days. So that's a DATEDIF function. It feels like kind of a one-off function, but it's pretty fun to use. So we're going to say DATEDIF. We just talked about that. If we scroll down, you can see we've gone through a grand total of 4 functions. Finished up what we wanted to do with the growth readings for the oak. So we'll come down and look at our next plant. We're only going to do 2, but this is one that's known for growing really fast. Right? So if you go down south in the United States, the kudzu vines are villainized because they take over any open spaces, right? We're saying they grow so fast that we're actually concerned with the hour, the minute, and the second. So we have more data points here because we have a day and a time. So that'll open up some more functions for us. But the first thing that we have to get over is that we're used to having the date and time in this format, right? So a different number in every cell. But the volunteer that happened to go out into the field to take the second reading just typed it all into one cell. So let's take a look at that. This is a valid format. So we'll say ISDATE. We'll come down and we'll look at it. And it's returning true. So you can see that in the blue font already. I'll hit the escape key. We don't need to do any more there, but what we want to do is we want to extract these values from it so we can do the calculations in a similar way. And there's 6 functions that we can use to do this. So let's go back up and check them off first because it's so satisfying to do this. We're going to use the hour, the minute, the month, the second, and the year. Is that right? 1, 2, 3, 4, 5. Oh, and we want to get the day too. So let's go back down. We're going to use all of those to take a date that's in one cell and spread it over all 6. So we'll start out with the year function, and then you just point it to the date and it's going to pull out the year. So 2022. And then the rest of these are going to work in a similar manner. And now that we've made both of these dates and times the same format, we can just calculate the difference in the same way. However, as I do this, keep in mind that this isn't going to be considering the times. So we'll do it real quick. All right, we come up with 30 days. So one observation right here is we're using the date function. And like we talked about earlier, we could just, let's copy this, paste the function into the cell. We'll take the days function, call off the beginning, change the comma to a minus operator or subtraction operator, clean it up a little bit, and you get 30 days again. So the only reason why I show this is because it gives us a little hint as to why the days function seems backward. It's because if you do it with subtraction, you have to use the start date first because that's the larger value, and then you have to subtract the smaller value, which is the earlier day. But neither of these functions are dealing with the time. So we're saying the kudzu grows so fast that the time of day is even relevant. So now we'll talk about how to deal with those times. But what I want to do first is I want to stop having to use a date function inside of the other functions all the time. It just makes it get longer and slows us down a little bit. So we will put it all together here, but we're also going to consider the time. So now we'll use the time function. Let's come up and check that off. So we'll make these a little bit easier to work with. The planted date, we're going to use the function we've been using, but then we're going to add something to it. So we'll do the year, month, and the day. But now in the same formula, we're going to append the time to it. So in order to do that, we'll use a function called time. And like the date function, this accepts 3 arguments, but in this case, it's hour, minute, second. So we'll take the hour, the minute, and the second here, and we'll look at what happens. All right, so that returns a value now that has a date and the time in one. So adding the 2 together just makes the date more precise. We'll do that for the end date here, and then we'll talk a little bit more about how these are working. So these are 2 date and time values, and let's pull them apart to look at how your spreadsheet actually uses them underneath. So if you just use dates to identify a certain day or times to identify a certain time, you never need to know this. But if you start working with them, adding, subtracting, it's helpful to know how they're put together. And in order to do that, we're going to use the date value function and the time value function. So first, of course, let's come up and check those off. Date value, and time value. So we're up to 13 functions now. And we want the date value from August 2nd. So let's type in date value. All right, so let's use this date value on September 1st. So I'll just copy it down. And you can see pretty easily there how you can subtract dates because they really are just numbers. And the time value function, we'll talk about what's happening here. We'll run that on August 2nd. So before we do this, you can see it's slightly over half. And that's because that time is just after noon. So it's a little bit more than halfway through the day. So when I press enter here, time value returns a fraction of a day. We'll copy it, we'll paste it down here. And when you combine those, this number that it's showing here, if I hit escape, this large number, that's how a spreadsheet is looking at August 2nd at noon. All right, so that's how it renders it underneath. And then that's what allows us to work with dates and times. So if we just calculate the difference between the two by subtracting them, you see it's 29.876 days. But if you want to say that in days and hours, minutes, and seconds, we have to do a little bit more. What we can do is we can subtract the 29 off of it and say that that's the number of days. So we'll come down into L77. And what we've done is used the truncate function. So truncate just chops off the decimals, right? It does not round. So it takes 29.8, it truncates it to 29. And then we'll use the remainder of that. So we will take the 29.876, pull the 29 off of it. And that's what we've done here. But you'll notice the format is changed back to time. So we're saying 29 days in 21 hours. And I'll show you how I got that to look like that. So when you go to format, you can control the way it's displayed here. So the formatting, it's not changing the actual underlying value, but what we're doing is we're saying, hey, this one is a duration. It's not a time of, because we're not talking about 9 p.m. We're talking about 21 hours. So when you use duration, it doesn't put an AM or PM on the end. It'll just show it as a straight hours, minutes, seconds. So that's what we've done here. So we've seen that the kudzu vine takes a little bit less than 30 days to grow 1 meter. All right, so we've completed that first part of our study. And what we want to do is we want to plan when to go out again, right? Because scientific studies, you have to keep looking for more information. So we want to go out and see when these two types of plants reach 5 meters tall. And we're saying in order to do that, we have to use a lot more date and time functions because we're going to be looking into the future. And as we transition into the planning phase, this will just be more of a series of individual calculations, but it's still a good way to show these unique functions that they built. So the next thing that we want to do, we want to plan our next trip, okay? And we're going to say it's when the plants are 5 meters tall. Maybe it's when the kudzu are 5 meters tall. That's probably already done. Let's say it's when the oak is 5 meters tall. So we're going to shoot for some time in the spring. So we went out in December. Let's say it's about 3 months after that. So there's a neat function called EDATE, and that will take a starting date and just go X number of months forward or backward. So let's find our December visit. I think it's one of the ones that we have to put together. We'll scroll up here and grab these 3 values. We'll say it's when the oak was 1 meter tall. So we want the year, the month, the day. We'll go back down. And now the parameter that it wants is the number of months. So you would think, well, you can just look at it, right, and add 3 to December, you come to March. But functions like these exist because you might be doing this on 50 or 5,000 dates. We'll do 3 months forward, and that's saying that's March 10th. All right, so we will close that off. And March 10th is just an estimate, right? So it's going to look a little bit cleaner if we just say March. And usually when you do that, you just specify the first or the last day of the month. So the EOMONTH function, we'll just pull up the last day of the month. So we can use this as a start date and just say we're jumping 0 months ahead, 3/31/2003. And this is another example of a date function where, yeah, you can just do it visually, but one, this is dynamic. So if the date that's feeding into it changes, it will change. That's a big reason to use a function. And this particular function will know how many days are in that month, even if it's leap year. Ooh, can't forget to check these off, right? EDATE, EOMONTH. So I put them on a separate worksheet here so we don't have to go back and forth quite as much. We just did EDATE, so we're going from 13 to 14 done. EOMONTH. All right, we're through 15. Let's go back, and we're going to use an interesting function called today. And this is a function that's aware of today's date, today being when I'm making this video. So we'll go over to the right here. We'll just do the today function. And what's popping up there, you'll see it knows that I'm making this video on Halloween in the United States 2022. It's October 31st. So there's lots of different applications where you can use the today function, but do beware if you open up the spreadsheet the next day. So for me, if I open this tomorrow, that same function is going to return something different. So in this case, it would return November 1st, 2022, right? Which tomorrow will be accurate. If you don't want that to happen, you have to copy and paste it as a special value or just hard key today's date in there. But let's see how many days we have to prepare. So we're saying we're going out on March 31st, 2023, right? So we'll grab that from H94 and we will subtract the value of the today function. So that's telling us we have 151 days. So we have some time, right? But let's say we're doing this study for a university, big organization, they always want to have a budget. So we're going to segue into some more financial considerations here. So these functions that we're going to be looking at, wait, let's check off today. Hold everything. Go from 15 used to 16. So we're going to say this project is going to cost roughly $100 per day, and that's for administrating the project. But it's only $100 per workday. So there are functions that are aware of, this is usually going to be 5 days a week. That's the network days. If you have different work days, you use NETWORKDAYS International. So that way you can specify exactly what days are your work days. So let's just do network days. And the start date is going to be a function a lot like today, but there's another one called now. So let's just use now. And that function returns the current date and the time. So the NETWORKDAYS function will actually truncate the time and get rid of it. So you could and probably should use the today function in this example, but I'm throwing the now function in so you know that one, if you need the date and time, that's how to do it. And two, you can use it in a date function that doesn't need the time. It will just throw the time value away and go from there. So we're going to throw it in there. And then the end date, we're going to grab that from H94. That's the end of March. And if I hit another comma, you can see that this is asking for holidays. So you can subtract holidays out if you want. And like we said before, if you were using the international version, you could also customize which days are actual work days. But we're good on this function for now. And we'll say, hey, we have 110 work days that we have to account for in our budget. Let's check off these network days, and now we're getting through these. There's more checked off than not checked off. And now we'll just do some simple multiplication, see how much it costs. We said 110, and we said $100 per day. All right, $11,000 we need in our budget. All right, so that cost is a little bit higher than we thought it was going to be. We're getting a little nervous, so we want to double check our math. So there is a function that can go backward. So it's called workday, and we'll type this out. And that's going to return a day, a specified number of work days away. So it's just going to do the same thing backwards. So we're going to say from today is our start date. Okay, I just had to pause the video and figure out why this was returning April 3rd, 2023 instead of March 31st, which I was expecting it to return. And let's just talk about the difference between these two functions, and I think we'll have an understanding of why. So if you use NETWORKDAYS and you look at the amount of time between 2 days, so we'll say today, and then we'll say today plus 1, which would be tomorrow. We need to change the formatting of that. NETWORKDAYS returns 2 because it's counting the start date and the end date. But if you use Workday and look at a start date of today and say the number of days away is 2, it will bring you to the day after tomorrow. So we double checked our math. We did find that these functions count days a little bit differently, but it's really close to March 31st, 2023, right? I'm going to show you another trick that I was using when I was troubleshooting this, is if you type in a valid date. This won't work if you type in a formula that results in one, so that's why I'm hard keying 1. You come and you double click, you can get a little pop-up calendar, and this can be helpful if you're trying to figure out how it's counting days. So if you're looking, is April 3rd to April 4th 1 day, or is it 2 days, right? Or you have 7, 14, 21, or 5, 10, 15, on and on. This little pop-up of a calendar can kind of give you a nice shortcut to figure those things out. We'll hit delete and we'll move on. But the most important thing we have to do is make sure we checked off now. We'll definitely check off the 2 Workday functions. Let's come over here. What we got now, Workday and Workday International. And now we're going to knock out the WEEKNUM function and ISOWEEKNUM. So let's come back to our spreadsheet, scroll over to the right to get our story. And we're saying the HR department's contacting us and they want to know how many pay cycles do they have before the next outing. So they pay every week. So what you need to do is figure out the current week number. So let's say WEEKNUM of today is 45. All right, and ISOWEEKNUM would work in a very similar way, but the ISO standard counts weeks a little bit differently in just how it defines the beginning and the end of the year. But their core functionality is the same. They would both allow you to do what we're doing now. So they count the number of weeks. So we'll say, what is the week number for the outing? So we'll do week number again. We'll come up, we'll grab 331. Whoops. 331, 2023. And that's week number 13. So how many weeks away are we? We can just say, let's just do this the easy way. We'll say 52 minus 45. So that'll be the weeks remaining in this year. And we'll add 13 to it. All right, we're getting really close. We just got through the WEEKNUMs. So WEEKNUM and ISOWEEKNUM. And now we only have 2 left. So let's go back to our spreadsheet. So let's make sure that this day is a Saturday. So we're trying to line up volunteers. I don't think we'll get a lot of them if we do it during the week. So there's a function that returns the day of the week as a number. So we will say, we'll just do 331. Close it off. And it's returning a 5. I actually think it's a Thursday. Let me go up to sheetshelp.com and we'll look at the weekday function. So we did not specify a type, so that defaults to 1, which means Sunday is 1. So Sunday, Monday, Tuesday, Wednesday, Thursday. So a 5 is a Thursday. Let me come back and update this documentation on the sheet that you can use. And one more interesting thing before we move on. So on this weekday function, if you scroll down on the website, there is a neat way to turn that number into the name of the week. So you just wrap it in the choose function and then return these names for each of the corresponding numbers. So this one will result in just the letters WED, make it a little bit easier to read. But I digress. Let's go back. We're wrapping it up. We're getting close. Let's check off weekday. And the only thing left is this kind of strange function called days 360. I'm going to check it off here. We're going to come back, and I left it for the end because it doesn't really fit in what we're doing. But what we're going to do is we're going to say we need funding for the project, right? So we figured out how much money it's going to take. Let's say we don't have that money. So that's going to move us into the financing area, right? So days 360 is categorized as a date and time function, but it's really only used in finance. So it kind of straddles between the two worlds. So I had to make a little financing scenario here. Let's go down. And I'll link to a video right now about, oh, there's me on another device that I'm using to read through this. We'll ignore that. Scroll down. I'll link to another video that goes more into the days 360 function because it's pretty interesting, and making the video helped me to learn more about it. But what it is a method that the banks use to count days. So if you use 360 days, one, which will show you, you can charge a little bit more interest. But two, it can also be used as a simplification technique because you just use 30 days for every month, regardless of the number of actual days in the month. So if you look at the days in between, we're going to say start on November 1st, end on October 31st next year. So this is a year, and I made it a year so you can see this simply. Let's just do subtraction, although we talked about the days function, but we also talked about how you really don't need it. There's 365 days in between these two dates. But if you use the days 360 function, it wants a start date. We'll give it November 1st. It wants an end date. And then you can specify a method. I'm in the United States. We're going to leave it as the default. There are some European methods. They work very similar. Again, looking at that video will help you if you want to learn more about it. But what this is doing is 30 days a month. So you can see in the result, I'll close this off, that it counted 360 days in this year. And where it gets really weird is that a bank can use something called the actual over 360 day counting method, and they would calculate the interest like this. So they would take the principal, 15,000, multiply it by the percentage, 15,000 by 5%. You should be done at this point, right? But not if you're counting days as actual over 360. So what you would do is you would create your numerator with the actual days and your denominator with the days counted in a 360 day. So that gives you $760 of interest. If you just did this 15,000 times 5, like a normal human being, you'd have $750 of interest. So the days 360 function will let you calculate how much interest you're going to get charged at the banks. Put in your fine print that they're using the 360 day counting method. So throughout this video, we input times using the today function. We did it using quotes and numbers, and we did it using cell references. If you want to understand more how those work, this next video that's up on the screen right now will just take you through a primer on how to use dates and times and formulas. I'll see you in that next video. Thanks for watching. It's nice to have you along.